Hello, everyone. We're happy to see you here for our next remote Flutter Hamburg meetup. Today, we're having a very nice lineup. But before that, I would like to share some nice news. It's Flutter 2.5 was announced yesterday, which is quite cool and a coincidence from our side. Another thing is that today we are going to do a giveaway, a lottery, and that would be this socks. So if you are from Germany, write in a YouTube chat, give me socks, and at the end of the meetup, we will roll the wheel and we'll decide who will receive those. Yet now let's go to the agenda. Today we're having three speakers. First one is Kevin. He will talk about GetX and how it helps you to build clean Flutter apps. Then we have Renee, who will talk about 3D representation in Flutter. And finally, we have Vince, who will talk about Dart null safety and how to migrate to it. That's our lineup for today. I hope the people are coming in right now, and probably we can already start with Kevin. So let's start it. And here is Kevin. Please
Hey.
feel free to introduce yourself, who you are, what the topic will be about.
Yeah, so hi, my name is Kevin. Maybe some of you know me. Me and Mike, who sits behind the scenes, we founded the Hamburg meetup 1.5 years ago. It was the only meetup where we saw all the people in person. And I really hope that this time will come back because that's the best thing about the meetup, right? To talk with each other, to exchange. Yeah, so what I'm doing, I'm usually worked all the time in startups in tech and product. Right now, at the moment, I'm working in a startup called Upfit, where we also just released 1 month ago our new Flutter app, which is called not Upfit, but Vanilla, because we rebranded it a little bit. And yeah, I used a lot of GetX there. And today I want to share my experience. By the way, if you want to download the Vanilla app, it's Vanilla with W, not with V. And if you like it, 5-star ratings are always welcomed. Yeah, that's about me. Should I start right away and jump into GetX? I think so because my screen is shared. So I was thinking about what's the best way to introduce GetX, and I decided to do it with screen share and live coding because the presentation would not give all the details. So what is GetX in general? In general, it's a fucking huge framework. It provides a lot, but still also on the other hand, it's kind of lightweight because you don't have to use everything. If you want to go in all the details, here is the Flutter package, GetX package website, where you really find a lot of information. It's really, really, really a lot. And at the end of this page, you will also have a lot of those nice articles. So it's really well documented. But not everything is documented, and that's also the reason why I decided to make this talk at all, because I had some pitfalls, and I hope that you will not have those pitfalls. So therefore, I wanted to show you a little bit of the things I realized, and just with some long debugging sessions realized. So that's also one of the reasons why I want to show you GetX. In the end, it's on the same level with packages like Provider or Riverport or these or inherited widgets. There's just one big difference, and this is why I like it so much. And this is also why I talked in the title of this session about clean app, because I really like to separate views from all the business logic. And when I say clean, I don't want to talk today about clean code or about clean architecture and all the stuff, but in the end, really about how you can get rid of things like the context, which I hate so much to share between my widgets and backend logic, because this always forces me to import Flutter into classes where it has no other reason to exist but the context, and that's something I really hate. I don't know about you, but that's one of the things I like the most about Get. And on the other hand, it's super performant and has a lot of nice tools which I want to show you. The typical starter, or what I want to do today, first of all, I will refactor a little bit the classic Flutter starter app to show you how it works. And then also I prepared some examples. I want to guide you through some more details. So as you all know, right, there's this typical Flutter counter. And when I click this button here, then the counter increases. So now we want to create it with get. And the very first thing we will do to make use of get is that we say, hey, we don't want to use a material app. We want to make it a get material app. Of course, now I have to import the library get. But just with this small change now, we have get in use already, which changes nothing. But behind the scenes, now we have memory management from provided by Git. I will just close my Slack. Sorry, guys. Okay, so now the very first thing I want to do is the core of Get is always the GetXCounterController. So what I do now is I say, okay, I want to have a counter controller, and this one extends the GetXCounterController, right? Pretty straightforward. And if you just check with on, you can see the typical lifecycle classes you can override, like start, ready, init, delete, close. Everything is well documented. So I don't want to go into the details right now. I will show you just how I make use of it. So the GetXCounterController is something which kind of magically will be injected to our widget. And the current widget we have here right now is our stateful widget. I will also rename it because it's not our homepage. It's our counter page. Sorry. Of course, we need a capital letter here. It's our counter page, and I definitely don't want it to be a stateful widget anymore. I want to make it stateless because we don't need stateful widgets when we want to use get, because get completely makes them obsolete. Therefore, I will also extract this logic here, our counter logic, and also will add the missing bracket here. And I will just move it over here. So the very first thing is we have our counter here in our counter controller. I'll make it private so that it's not changeable, and I also provide a getter for it. So counter, and then let's create increment. We don't need set state, but of course increment will still increase our counter because it's what we are aiming for, right? I don't care about the title, or let's just move the title also to the controller. Then we don't have to give it to the widget, and our widget is purely called without any parameter. Even better to have it this way. So final string title web, make it this way. So then we can call it here. So now you can see we have a lot of problems here because we need a controller. The easiest way to get access to a controller is with a single line of get put counter controller. And now with this single command, get automatically brings the counter controller into our memory management. And now the counter controller is accessible from everywhere. We don't have to inject it. It's really accessible in all the widgets which want to make use of it. One way to do it is get find. And I will create a small getter function here. So let's say counter controller, and then get find. So because we already have the class defined here, counter controller, getFind will definitely give me the right controller because there's just this one instance of counter controller. You could also give it a type, right? As you know here, you can enter the type if you want, and then you don't have to define it here. So, but getFind, as long as getPut was called, getFind will give you the counter controller. And now we can easily say controller title, and we can also say here controller counter. So now our counter will be there, and we can also say here controller increment. Why do I have this error here? Controller increment. The expression is a type of void. Yeah, man. Okay, so now the code compiles. So let's just start again so that we have everything in memory. And when you go now to the debug console, you also see that after the reload, we have the get material controller, which is created because we have our get material app, as we did here. And we also have our counter controller, which is instantiated because we said get put here. And now we also have our counter controller available. What you will see right now is when I click plus here, nothing happens, right? So no counter is increased. But if I do a refresh here, you see that the counter is there. It's just the refreshing is missing. So to achieve this, we will add a few things. First of all, after the counter, we say update. So now with this update call, every widget which uses the controller will update, but not out of the box. So to update, we also have to make sure that we have kind of a get builder around it. So we take our scaffold here, and now we say wrap with get builder. You get out of the box also here with Visual Code, for example, these automatic code snippets, which is really helpful. And in the get builder, you say, of course, what kind of controller. You could even instantiate it here, which I will do because I hate this here. I don't want to call in the build function something like this. So let's make it a little bit cleaner. And let's say here, counter controller. So now we have an init function here. You don't need this init function. So whenever this controller is already put on another place, you don't have to call it. But here, because we want to initiate it too, we call it. You could also give it an init state, which we would not do right now, but that's also possible. So now let's again save this whole thing. Let's also make a hot reload. And now, hopefully, yes, it works. And our counter just increases, and we have a clear, clean widget where we don't, by the way, we don't need this anymore, because what we also can do is we give our controller here. So that we are also rid of this whole thing, and it still works. So our counter increases, increments as it should. So pretty cool. And we have all the logic here. We have no stateful widget anymore. What is still a little problematic, if you think about it, is like, okay, this builder now always rebuilds the whole scaffold here, even if we just update our small text function. So we still can improve. And I want to show you two things. First of all, how we can get rid of get builder, and also how we make use of our material app in a much better way. So, and to do this, I want to introduce to you a concept which is called bindings, which is also really cool because you can call bindings with every page you load. How this works, let me show you. We create now our counter binding, and it extends bindings. And you can see we miss, of course, a class we have to override. And now we say here get put counter controller. And now when this binding is called, our counter controller is created. So how we do it, we just say here initial binding in our app, and then we give it our counter binding. So now we know that the counter will be here for our counter page with the initial binding. And even better, we don't need this wrapper here anymore, the get builder, because what we will do now is we make use of get view. Get view counter controller. what this is doing here, getView makes sure that your controller, as long as it is already available via this binding, is available to your widget. And therefore, we don't need this getBuilder anymore. We can just say, we return to our scaffold, get rid of this. And what we will also do right now to make it even less codey is that we don't use just getBuilder, but we use obx. Obx is the reactive version of getX, which is even cooler because we don't need this update function anymore. So you will see that now our controller, he will be super small, super tiny. So let's make this counter an rxint, yeah, which means we have a reactive integer here, rxint counter, and when we initialize it, we call obs, like observable, right? So now we have here a counter which is observable. So we don't need to scatter anymore, and we also don't need this whole increment function anymore. This is right now our only controller. I just want to show it to you because, of course, this has a side effect because now this variable can be changed, and that's maybe not what we want, but to just show you how much you can reduce the code, and as long as it's no problem, because anyways, we want to allow our widget to change this counter variable. This is really the minimum of what you need to have a reactive widget. So we have now the counter here. We have our binding, which is called, we have getView here. And now the controller is already here. So we will load the title. We will have our function here, which we now change because now we say, okay, on press counter plus plus, counter, not count, counter plus plus. So this is now our new increment. And now what we do, we take our text widget here, which we want to update, and just this one, we wrap it with obx. And in obx, you just give it a function with the widget, and that's it. So now we have our obx widget here. We give it this text widget together with the controller counter, and now only this will update. Everything else will stay when we update. And you will see that with this reduced code, it works as it should, right? So this is really how much we can reduce it here, how much we can make it more efficient. So that's how we refactor this whole Flutter test app to make use of Get. What I want to show you now is a little bit what else we are able to do. And before I show you how things work, I want to show you a class which is called navigation. And this is how I do, from my point of view, a clean navigation with GetX, which I really like because there is no context needed and it's pretty straightforward. So what I do, first of all, I like to have everything really readable. So I create an enum here, which I call navigation root. And then I say for my navigation, I want to have 2 pages, right? Counters and counter. I will show you the pages later. And then I create also an extension, which I call details, on my navigation route. And this extension gives me the name of the route. It's just a switch, right? Based if I'm the counter, it's slash counters. If I'm an navigation counter, then it's counter slash counter for the details page. The default is just slash. I also have a widget called page, where I say, okay, if the root is counters, then give me the counter page, and so on and so on. And also binding, which is also nullable because not every page needs bindings. And here I can also then say, for each root, give me the bindings. And why I need this, I tell you, because now I can create a navigation service. And navigation service here is a GetX service. GetX service is something like our GetXCounterController. What is the big difference? A GetX service is always available. If it is instantiated like a singleton, it's available and it's never leaves the memory. Yeah? That's something when you need access to a specific API or something like this, could be super helpful. But GetXCounterController, for example, when the view who uses the controller is out of our widget tree, also the controller is deloaded from the memory, which is also super effective, right? There are some pitfalls with this. I will tell you about this in a few minutes. But what we do here in the service, we return pages, a list of pages. And what I do here is I say, okay, from all the values from my enum, so it doesn't matter how many roots I have, please map these enum to a get page. And the get page gets the name, gets the page widget, and also the binding. And then I just return it. And then I have a mixin, which I call navigation provider, so that I can make my navigation service easily available to every kind of widget who wants to use navigation, or every kind of class who wants to use navigation. And also here, this one calls our navigation service. Here you see this example with the type given in the find behind the find function, where we get our pages. And we also have navigate to, where we would accept our route. Then also arguments. I will come to this in a second. And then we call get to, and here the name of the route and the arguments. And this is also how navigation works. Yeah, this is everything get needs. We have all the pages. And when I say, hey, get to named, then I will go to this page. It's super straightforward. And also here in the mixin, I can define what is my home. Here, the home is our Countess page. Why I'm doing this? Let me show you how we can now change our main app a little bit. Because now we say, hey, I want to use my navigation provider. And we don't work with home and we don't work with initial bindings anymore. But what we do right now, even we don't need this, right, guys? We don't need it. So what we say now is we have get pages. And get pages will get the pages. So I just have access to the pages because of my mixin, right? So pretty straightforward. And I also have my initial route, and the initial route is my home, which is also defined in my mixin. So now when we reload everything, the one thing missing, as you can see here, hey, the navigation service, which I'm so happy with, is not available. So I also have to load it, and I do it here because this is what I need from the very beginning. And then we say navigation service. We reload again. And here we are. Now you can see the new page I already created with multiple counters. But this is really straightforward, that the whole navigation is now handled just because of the pages here and the home we talked about. Yeah, nothing more is needed. And then we see our Countess page. And what I want to show you here on the Countess page, it's kind of a live coding together with prepared stuff. So, oh no, wait a second. Countess is here. So you can see that here we have a Countess controller, and the Countess controller, where does it come from? Why do we have it? Because it's defined in our binding that whenever we go to the root Countess, which is also our home root, the Countess binding is loaded. And when we go to the bindings, you can see that the controller is there. And you also see it's always here what is instantiated, what is not instantiated. And then, wait a sec, Countess. The Countess controller has just a list of indices from 0 to 2. And they're wrong. Sorry, guys. Here's the right one. So here we have a list of indices, and we also have our bindings here, and we have the counters page. So now we have multiple counters. We build them here, right? The indices are mapped to counter card. Our counter card is just this card here, where we can decrease and increase, and this will change our counter. What you see here right now is, fuck, this was not how it should work, because I wanted to show you that all counters will change together, but I think here's something wrong. We already load the refactored one. But because I also see that we have a little less time, let me go through what I want to show you in the already done stuff. So usually when we have multiple counters, right, and we would just have one counter controller, they will all, this plus button would change every counter. Yeah. But what we do here is that we say for each counter card, we create a counter controller and we give it a tag. Yeah. So the tag is nothing more than our indice to string. So instead of integer 0, it's string 0. And now we have a counter controller. And when then we go to our counter, to our counter card, which is here, because we use getView with counter controller, we also have now with getView a tag, and we can override the tag. And this is what we do here, because now we say, okay, each counter card gets the tag, right, which is the indice, and then it automatically will call the right controller. So you can even have in a long list separated state. So this tag helps you with the same controller to separate state between multiple items like them here in the list. Okay, so that's really, really helpful when you want to do this. No more magic here. I mean, the counter uses the controller. Everything works as it should. Let me just check on my notes what I else wanted to show you. The routing I showed you, the text I showed you. Yeah, exactly. So now in the counter controller, we also have the navigation, right? And here, when we have navigation, we do navigation route counter, right? I showed you with the mixin. And here we also have an argument, which is our counter argument index. With the index of the selected item, and then we go to our counter, which is the counter page we had in the beginning, right? But we also gave it an argument, so you can really see here counter is 2. When I go on this one, counter is 6. So with this argument, which we use in the detail view, we also have the right counter information showed here. Something I want to show you, because we use arguments here, and I think using arguments is something we do a lot when we switch between screens, and I had some trouble with it, is the following thing. What I usually do, right, and I can show you here, print argument, and we say get arguments, because this is how we get arguments, right? When we have a page and we want to access the arguments we used before, we do it with get arguments. And something I want to show you right now is a behavior which makes your arguments go away. What I mean is, right now, just to be sure it's fresh, so we come in here, we are on our page, and now I say print, right? And you can see here it is printed, our argument. It's 0 because there is no toString function for argument, but that's the index, right? We have, and now I do something different. Now I say snack me, and snack me shows a snack bar, which, by the way, is an interesting and funny feature. Here you can just see it. You can say get snack bar. You just give it a title and a message. You out of the box have your snack bar. You can do the same with dialogues or alerts. So you can really get rid of a lot of code with using get. But in the moment we show the snack bar, and you can also see it here in the logs, there we have open snack bar and close snack bar. So it's like a new route. So this means if I now say print me, oh, it shows still the argument, but the argument will be gone, I think. I don't know why it's not gone right now. But what usually happens is that as soon as you show an alert, a snack bar or whatever, in a bottom sheet, your argument will be gone, because it's like you go root forward and root backward. So therefore, what I did also already here in this code is that I really persist the argument with the tag here. So what I say right now here, when I construct my counter page, that I say, hey, my tag is the get arguments, counter argument, and the index. And that's right now always there, even if I do another route. Yeah? What I did before, and therefore I was really going nuts. I show you what I did. Arguments, get arg, zack, get arguments. I did something like this, right? Now I know it. So I did something like this. So kind of on the fly, I was always asking for the arguments. And then I was wondering why my app was broken after I displayed a bottom sheet. It took me a while to understand that this is the case. I was really going step by step through my app. If you can avoid it, do it like this, okay? So make sure that you really store it with a variable in your widget when you want to access it, and especially when you want to show other stuff. Okay, man, we are running really out of time, I think. What else do I want to show you? So maybe just fast here, another example when we talk about the clean app. That's also here an app where I created. I can show you the app. Just a second. App. It's our example app. Started. So here in this app, yeah, we have Get Material app, we have our homepage, we have our service bindings, and here we create bindings for our services, because this app is a little example how to make use of multiple services. I have my authentication service, a commerce service. They are really just super simple here, a marketing service, and I have some views here. And here I say lazy put instead of put. So that's really cool, because these services, I already in the beginning say, hey, I want to create my service bindings, but I don't know if these services are really called. For example, in this example app, I have to be authenticated to see the e-commerce products, right? And therefore, I don't know if the commerce service is ever used. So with lazy put, we have something like late initialization. So we just create and bring our service to memory when it's used. So that's also super effective. Something important is also when you use get lazy put, that you also understand, hey, whenever the view or the widgets, the page which using it is gone out of memory, the service is also gone. Yeah, so that's something which should be important for you. The GetXCounterController, not the service. So and here you can see already that the material controller is created, the home controller is created, the auth service is created, but nothing more. And in my home page, you will also see that here I make another use. I use the state mixin from Get. What is a state mixin? You can see here I created my scaffold, and also here I have created my controller.obx. Yeah, so controller is my home controller, which I will show you. And then I make use of .obx. And here I have the possibility to receive a specific state, right? Or I can react on specific states, like on loading, on empty, and on error. So when I load something, I show a circular progress indicator. When it's empty, I show nothing. On error, I show error message. Or when I receive my user, I will check if my user is authenticated. And if so, I will show the product view. Everything else, I will show the login view again. So how it works, I click login here. You see I have a small delay here. And now the product is loaded. And I can't tell you everything because we have not so much time, but I just want to show you a little bit what is possible. So what really happens here is that we just always say, hey, first of all, ever, yeah, we have this cool everything. So we have our auth provider. Our auth provider gives us a user Rx variable. And whenever it changes, this is our ever worker, which is out of the box there. So whenever this changes, this callback is called. Yeah? You have ever, you have once, you have debounce, which also means that you will just react after something changes for a while. For example, when you want to create a search. So a lot of cool stuff. Make a checkup for GetX worker. That's another awesome feature GetX provides you. And what I do here is whenever the user changes, I will check if the user is authenticated. And if so, I will also create the controllers I need. And then I also call change. And change is then gets the user object and also the new status, which is success. Yeah. And this is how in our home controller we can react on it. Yeah. So this is how, wait a second, where was my home here? Already too much open here. It's already here. Yeah. So this is how here the states are represented in these on loading, on empty, and this user one, this is on success. So this is one example. Another thing also, the last thing, and then we are done. I want to show you is here we have a controller which is created, right? Our purchase controller, and we use this controller for this small button here. And also here, and they're completely separate. You don't have to send the controller through other controllers to it or something like this. You just have access to it. And how it looks like is when we go to our product page, I have here, this is my cart view. And here's no one talks about the purchase controller at all in this products view, right? I have my carts view here, I have a product list item, and the product list item has a purchase button, right? And the purchase button uses the purchase controller. So here I have my purchase controller. I have my purchase button, which is get view purchase controller. And I have my cart view, get view purchase controller. They don't know each other, but they both have via get view access to the same purchase controller. And this also means that they are reactive, right? So when I now say I want to add this iPhone X, the total is already updated. And if I also do it with multiple ones, it's always updated, even if they have nothing to do with each other, because they have access to the same controller. I think I will share with you the code snippets from the example from the counter, because I really had to rush through it. But I hope that maybe you're a little bit curious about GetX, and maybe you realize that I'm really a big fan of it. So this has been a little bit of examples. I hope it was not too fast. I hope it was not too much, and that you learned a little bit. At least you are curious. Man.
Thank you, Kevin, for such a great presentation. It's actually a very interesting topic also for me, because I used GetX in one of my pet projects, and I actually have one first question to you right away, because I thought about it, that GetX is nice for small or maybe medium scaled project, but what about the large scale? So like I was thinking how it will actually perform there. What is your take on it?
Depends on what is large scale, right? I mean, I use it also right now for the vanilla app, which is already kind of complex, I would say, and it will be more complex over time. And this is also why I like GetX, because it has all of the boxes memory management, right? And I think what is important on with every kind of framework you use is that you think carefully when to use what, and when to instantiate which controller, and when to make what accessible. But I think it can scale, and that's also they're there on their own documentation. There are a lot of benchmarks how GetX performs versus other tools and other frameworks, and they always look really good. I never realized that there's a slowdown or something like this based on this framework. Really, the only problems I had sometimes is that the documentation is awesome, but some hidden things are missing. But from a performance, I think you can make it with a huge product or a huge project, as long as you really separate things from each other, things which don't belong together. And that's I showed you a little bit this lazy put example, right? I mean, controllers or services, they should just be loaded when they are needed, and and also they should get out of the memory, right, when they are not needed anymore. And I think that's also then something you can do with your with GetX in a really good way.
Awesome. Then we have one of the first questions is, what about testing?
Yeah, testing. That's also one of the reasons why I really like it, because you can test in a really good way, and there's also test support, also mock support described on their page, on their documentation page. So when you want to get details, go in it. But what I really like is, and what I also did on my own, for example, right now you saw that with GetView, I always defined exactly my controller, right, counter controller. But what is really cool when you want to inject, for example, a test or a mock controller. So how I do it, of course, I create an abstract class for my controller. Let's say my purchase controller abstract, right? And define everything. And then I define for my widget a type I give it. And then I can decide based on the type if I give you a test controller or the real controller, right? And out of the box. And that's really powerful. And from my point of view, I always hated to test with Flutter when I injected controllers or something like this to a widget, because it was really pain in the ass. And now it's like charm. So it's really well documented, and I think that the best case is really to abstract controllers and to inject them via type. If you want to have some more details, maybe you can also send me a message, and I show you some examples about it. But
Nice.
especially for testing, and this is what I really like, it's really cool. And also you can really separate things. I mean, I talked about navigation. You can now test navigation in a really good way, right? I can easily say, hey, whenever I give this name to my navigator, do I get the right route? Is the right route called and all this stuff, which wasn't that easy with all this context blah. With provider, for example, I used provider before, and the problems I had with provider, especially with testing, I don't have them anymore.
Yeah, same here. Okay, let's jump to the next question. If our tech person will add this question to the screen. Yes, perfect. Did you encounter a situation when you need two different controllers in the same view?
Yeah, this was a multiple counter example I gave you. And when you talk about that, hey, you have one view and you want to have for this one view two controllers, because get view just allows you to have one controller, right? You can, first of all, you should ask yourself why you need multiple controllers on this specific widget. Maybe you can even separate and decouple it. But if not, make use of mixins. Get view is nothing more than a mixin with a so get view just gives you this get find controller behind the scenes, and maybe a little more with the tech and everything. But in the end, you can also use a mixin. At least this is what I do if I'm in the situation. But ask yourself why you need two controllers. I think you can then separate the code and make it even cleaner and easier to maintain.
Yeah. I see we have another question there. Probably this one. Do you still use a single global key? If yes, isn't that bad?
Good question, and I really don't know, honestly. I don't know. I have to check it. I was not thinking about it. So it's on my bucket list now to check it.
Okay, good. Then, do we have any other questions? So far, I don't see anything. I just have one question too. So, are you going to share all the code that you showed to us and some GitHub repository or not?
Yeah, I will make a GitHub repo and then I will share
Mhm.
it with you, and then you can share it with the viewers, right?
Yeah, awesome. Yeah, then thanks a lot. That was quite interesting. I hope also
Thank you.
for all the audience. And yeah, let's continue. But before that, I want to again highlight that write "Gimme Socks" in the YouTube chat if you want this nice shiny Flutter socks. Only applicable for people living in Germany. But yes, don't forget about it. And now we have our next speaker. It's Renee. Renee, please introduce
Yeah,
yourself and
greetings everyone. Yeah, I wish I could participate myself. I really like the socks. They look really, really delicious. But yeah, it's for the viewers, of course. But yeah, I'm Renee. You might know me. I'm an organizer for the Hamburg Flutter and Beyond meetup itself. Have had one or two presentations before that. And today I think I have a very interesting topic. And I think without further ado, let me just share my screen and go in. Maybe you've already seen my topic on the meetup page, but it's basically 3D representation in Flutter. So first of all, I don't know if you're familiar with that, but Flutter is using Skia on the bottom line. So if Flutter is showing something or drawing something on the screen, it's basically been done with Skia on the respective platform, for example, on iOS and Android and so on. And even the documentation from Skia says it's an open source 2D graphics library, and it serves as a graphics engine and is used for Flutter and other platforms. So the interesting part here is, of course, it is 2D, obviously. I mean, most of the stuff we do in Flutter is 2D. And the renderer itself, the Skia renderer, is based on 2D graphics. So sorry. And and this is the usual use case. You don't need anything more than that usually. If you want to do something with 3D, there are different kind of other libraries and stuff so on. But still, I was wondering, is there a way to do it in Flutter with what we have there? And if you, for example, I just made some small sample application here, I just put it in a cart and added elevation. Like there is a property for the cart widget in Flutter which is called elevation, and I just toggled it between 0 and 12. And this is a kind of 3D effect, right? So with having elevation, with having this drop shadow beneath it, it kind of feels like a 3D effect. It's not like real 3D or something like that, but it has this effect of being 3D in any way because, yeah, you know, it hovers back and forth or even just hovers. And you have this with multiple elements in Flutter. Like usually the app bar on top has the same shadow effect, not so strong as this here one, but you could adjust it and it has this small shadow effect, and you can do it with different kind of widgets to have this effect, and it kind of feels 3D-ish, but of course it's not 3D. It's, as we just read before, it's 2D and just mimicked with the shadow effect. Also very interesting, if you look in the Flutter documentation, and again, I can only highly recommend to look at the documentation from Flutter itself. You can see the link beneath. It's flutterdev/docs. You can find a lot of really helpful information for a lot of stuff before diving in any blog articles or something. There are great articles out there, don't get me wrong, but the Flutter documentation is really on point with a lot of stuff. And somewhere between the line in the page about architectural overview, it says most Flutter widgets are rendered by an object of fixed size in a 2D Cartesian space. What it means is Cartesian space is the one most of you know probably is this coordinate system with X and Y, and many could have even more axes, but where you say, yeah, I have a point which is like 2 in X direction and 2 in Y direction, for example, and you explain like that. There are different kind of spaces, like a polar space, for example. Maybe you've heard this. Also, it doesn't work with like X and Y directions or axes in general. It works with angles and lengths. So it's just a different representation of where a point is in a space. But yeah, usually we are faced with a Cartesian space, which we all surely have gone through school and college and so on. And and Flutter is making use of this as a baseline for drawing stuff, where they just use this Cartesian space to draw and align and lay out stuff. Another very important point is every object has a defined size within its parent's constraint and is ready to be painted by calling the paint method. So in the end, this is what I was referring to. Every widget you see is in the end, or everything you're placing in Flutter is in the end being rendered, which means it's being painted. That's a very interesting information, just to make this clear for yourself. Like if you ever wondered, like how does Flutter even work? What does it do behind the scenes? It's basically painting everything with Skia natively on each platform, which is pretty nice and very good performance, as you all probably know when you use Flutter, that it even works so good while painting everything. I just thought it's very, very interesting fact. But yeah, it's good for us to know, because that is a good step into this into trying to understand how we can achieve 3D rendering or 3D painting in this case, even though we are limited of being 2D by the renderer itself. Also, a very good overview, which you can also find in the documentation again, is how it all comes down. Like, for example, we have a very easy widget tree on the very left side, where you can see we have a container. Don't mind the not colored with the dashed outline. Don't mind them. The actual widgets you will use are a container. Inside, the first child is a row, and the row has 2 children, which is text and image, or image and text. The elements which have this dashed outline are not actual widgets you would use or you will use. They are kind of created, and you can see it in the next step in the element tree, because there are before a widget is being transferred to an element and then transferred to a render object. So you can see like a container is being transferred to being a component element, and the component element is inside actually composing the actual render object. And the actual render object, again, is the colored box. So this is how everything goes down. Like from the left to the right, you have this actual widgets, which usually are just component elements. And inside them, they get some constraints, they get some information, and they will create the actual render object element. And the render object element, therefore, will create the actual render objects, like on the render tree, which will handle all the paint stuff and drawing everything on the screen. And I think this is also very interesting information. Usually, as a Flutter developer, you don't necessarily need to know that. Like, I've been using Flutter for quite some time already, and I wasn't even faced with everything besides the widgets, because usually you can just, as a developer, you can just make use of all the widgets and create your own widgets, and you get to get really far into Flutter development without getting anywhere where you say, I don't know how to solve this. You only have to go deeper with element tree and render tree if you want to do something more customized, I would say. And this case, what we do here is kind of customized, because we can't use any existing widgets for trying to display 3D objects. At least that's not how I tackled this. I thought, okay, I have to paint it. I have to get to the paint level and do it myself. So while going also through this documentation, all the stuff, I stumbled upon this render object class, which basically sounded what I need. It's an object in the render tree. And we saw, and beforehand, we have the very, very right side, which is doing the rendering stuff. And I want to render stuff. I want to render 3D stuff. So I thought, well, okay, let me just go with the render object one, because it's basically doing that. And it says the render object class hierarchy is the core of the rendering library's reason for being. Sounds very good to me. But then later on, if you go to the documentation, it's somewhere between the lines says, in most cases, subclassing render object itself is overkill. And it is because, and it says here, use a renderbox, because, however, if a render object doesn't want to use a Cartesian coordinate system, then it should indeed inherit from render object. So it basically says, well, if you really want to go to this render object stuff and want to extend it and want to do stuff with that, it's usually only the case if you want to avoid the Cartesian coordinate system. But for our 3D stuff, the Cartesian coordinate system is just what we need, just what we want. We want to have this different axes, X, Y, and Z, and want to display stuff with that. So we want to use a Cartesian coordinate. So maybe using render object class is not the correct choice here. And maybe we should look at the render box one, the documentation states. And looking into that, the render box class says a render object in the 3D Cartesian coordinate system. And that sounds much better and much more of what we actually need here. So then again, I went to the documentation for the renderbox class and was about to say, okay, maybe I can tackle my implementation with making use of that. But I made a small video going through the documentation here, where I just scrolled down and you can see the documentation which is there for the renderbox. And it's kind of long, and quite a lot of stuff you have to be aware of. Not that it's not possible. There are a lot of articles or even Stack Overflow posts from very named developers who explain it very well how to do it, and there are samples and so on. But it's still a lot to take into account, and still a lot to do. So I thought, okay, I'm not sure if I really want to go into there when I actually just want to try to make a proof of concept first to see, is it actually doable as I've imagined it, or how I think it could work. And render box was a bit overkill for me as well. Not only the render object, but also the render box for now. But we have something to solve this problem. It's called custompaint. Some of you might already know it. We already also had a talk about it, I think. One of our speakers talked about it indirectly, as he made a solution based on custompaint as well. And to guide you through why custompaint is a good solution for that is, if you looked on the documentation or the source code of custompaint itself, you see that the class custompaint extends single child render object widget. Sounds familiar? It has this render object stuff in it. Sounds not too bad. If we go even deeper, you see the custom paint overrides, since it extends the single child render object widget, it overrides the create render object method or function. And you can see that the type it's returning is render custom paint. Then I dug even deeper and saw render custom paint extends render proxy box. And render proxy box is basically just a different flavor of render box. So by using custom paint, in the end, we use this render box we just talked about earlier, which enables all this custom painting, but limits on what we have to do. Because as we saw in the render box documentation, there's a lot to take into account. It's not the case for custom paint, because custom paint does a lot for you and assumes some stuff based on size and constraints and so on. And this was for me the perfect starting point, because I thought it's not like I want to fix all the sizing constraint problems right away. I just need a way to paint stuff freely, and custom paint is just the way to go. And it's pretty close to the actual render proxy hardcore painting variant. So we are close and we can still use it. It's not too hard. If we look how to do it, we just write custom paint, since custom paint itself is a widget, so you can place it in anywhere in your widget tree as you like, and it has a painter property. The painter property accepts any class that extends custom painter. Don't mix them up. We have custom paint, which is the widget. We have custom painter, which is an interface. So in Flutter, it's an abstract class, and we have to extend it because it's abstract. It's an interface. You can't just provide the custom painter and create an instance of it. You have to extend it. So in my case, I just created a class which is called model painter, and it extends custom painter. And once we do it, we have access to the also mighty paint function. And if you look at the documentation, it's the first bit, of course, of the paint function. You can see that you get a canvas, and the canvas has this coordinate space configured that the origin is the top left box. So we know deep down we are using renderbox. So we have the coordinate space, which is like on the Cartesian space. So we have X and Y. And this is like perfect for us. We can overlook the size component now. It's not too important for now. The most important part is the canvas. We now have a function, a paint function, which is like giving us a canvas, and we can do different stuff on the canvas. It sounds mighty, and it's actually just what we need here. So when we look into the canvas itself and look at what functions we have there, you can see there's a lot you can do. And this is just a small snippet of what you can do on a canvas. You can draw arcs, you can draw an atlas, which is just like a specific part of an image. You can draw a whole image, you can draw lines, oval, and so on. You can draw a lot of stuff on a canvas, because as the name suggests, you can just imagine it being a plain wall where you can just draw stuff on it. You just have to explain how you want to draw and what you want to draw. And while going through this whole list, there's one which is like very, very good for our case. It's a draw path function. And then looking at an example of how you can use it, you can just call the canvas and then draw, and the draw path function, provide a path. And the path is basically nothing else than an explanation of how you want to move on your coordinate space. Like, for example, I want to move to the place 1, 1, like X is 1 and Y is 1. And I want to say, I want to draw a line to 2 and 3. And then another line from the point 2, 3 to 4, 2. And then I call close, which basically just go to the beginning. And that's how you can very easily make an actual path, like an actual way how you want to go on a Cartesian place, on your coordinate system. And then as a second argument, you provide a paint, and paint has additional stuff you can do. But like for this example, I just said, well, I want it to be the color red. So my path should be colored red. And if I use this, I just use some different numbers, because if I would use this one, it's pixel based, so it would be very, very small. I just took some bigger ones, and it made something like this. It's pretty ugly, don't get me wrong. It's nothing too fancy, but I mean, it's like you're just like an artist. You just have a whiteboard, and you can just say, yeah, I want to paint something just like that. As I said, it's not too fancy. You could maybe use something like draw arc or draw circle if you want to have some round stuff and do some more fancy stuff. But for now, you could just saw how easy it is to define a path, say you want to go to draw this path and have it to be color wet. Very easy, very straightforward, and very mighty indeed. But don't get me wrong. But the problem here is now this is 2D, right? So this is a triangle, but it's 2D. How do we get it to be 3D? And this is the next part. This is so-called 3D projection. 3D projection is what the name already suggests. It's trying to project a 3D element on the 2D surface. While I was investigating this topic and read about it, it was like, okay, there has to be someone who has already done it, right? Like, because it's not like your screen is 2D, right? So all the 3D stuff has to be ultimately be drawn 2D, right? Like, it's not like your screen is 3D. So something like has to exist. And indeed, 3D projection is a very long-lasting topic. It's not like it's new or something. You just have to know what it is and what it's used for. And it's actually just used for this case. The perspective one is the one we want to use for our case because since we want to display 3D elements with a changing angle, later on we want to being able to rotate about 3D stuff. The perspective one, the upper left one, is the most interesting part because you can see we have the 2D surface and based on where the point is on the right side, this is how the cube is being displayed on the 2D surface. And while going into this topic, you have to go to some more mathematical stuff. And I don't want to go into all the details because it's like a whole topic itself. And probably a lot of you or all of you, I don't know, already knows this topic. It's vector arithmetic. It's the idea of how to define points in a n-dimensional space and how some mathematical rules are applied there. Like how do you add them? How do you subtract them? How do you multiply them? And there are even different kinds of multiplication. So don't get me started. There are a lot of stuff you have to take into consideration once you go into this vector arithmetic information or topic itself. And I provided you a link which I used for some reference stuff where it's very straight down explained for the basics, the fundamentals of what to take into consideration once you think about vectors and stuff. And this is the baseline for going into this 3D idea. So for the next step, it is important to think, how do we actually represent an object, a 3D object? And it's basically what you can see here. On the left side, we have our coordinate system in the Cartesian space, which has 3 axes, which has the x and y, which you know from the 3D space, and the z one, which is for the depth. Yeah, so it's 3 dimensions we have now, and now you only have to have some conventions, some wordings for how to explain or how to model a 3D model. And there was 3 very important names or data types, you can also say, for that. It's the vertex, it's the edge, and the face. The vertex is basically just a point. It's just saying, this is if you take all the vertices from a model, you can see all the edges, all the points from it. Yeah, and it's basically just a vector. As you can see on the bottom, you can see a vertex is basically just a vector. Nothing else. It's just a combination of x, y, and z components in this coordinate system. Nothing more than that. And the edge is also not too complicated. It's basically just the pair of 2 vertices. And you say, if you have 2 vertices, the line that is between them is the edge. And so if you would take away the face for now, you would have like a triangle now with vertices and edges without any content. And to have content or faces or something that is on top of them, so you can actually see the outside of a model, you need faces. And a face is in the end nothing else than a list of edges. So for example, from the front face, you can see where the face is written on. You just need 3 vertices and 3 edges, which is connecting those vertices. Yeah, and having this in mind, having this idea, then you just have to think, how can I do that in Flutter And luckily, we don't have to do everything else. There is a package for that to model stuff like that. So there's a package called Vector Math, which is actually from Google itself, which says it's a library for 2D and 3D applications. For us, right? So we have the feature list, and the most important one is the first one, 3D, 2D, 3D, 4D, vector, and matrices types. We need that. And somewhere in the middle, it says utilities like color and common rendering related operations. Sounds very good, right? And the last part, yeah, well, Flutter uses it itself somewhere deep inside their code base. So it's pretty good to use it yourself if you want to do something like that. So the key concepts is basically you need a camera, because we said we want to mimic the perspective one. So you need a camera, which is basically just a vector, just a point in this coordinate system where you want to say from this point, I'm going to look from there. That's basically my camera. Then you need a light, which is also just a vector, just a position where you say from here on, from this position, we will emit light. Then you need to mimic the data types, which I just explained. You need vector or the vertex, which is basically just a vector, so it's given. You need an edge, and you need a face. You need to mimic this data types in Flutter in Dart. And the last part is the 3D projection, which seems like the very hardest part, but Flutter got us covered. You will see it right there after the slide. For now, I just show you here a very easy model. It's just like a snippet from a longer list of how a model would look like if you would just write it down by yourself. It's like the model class, a face, a list of faces, and a list of edges, and then the vertices. And this list it goes even longer. It's just for an easy cube example, and it got very exhausting just to write it down just for a cube. So that's why I somewhere between the way I just started to write an object parser, where you can just load an object file, and it does this for the object file. So I don't have to do it manually, because for bigger object it would take, I don't know, hours to make something more complex. But here we can see the actual magic that is happening. On the top, this is the view matrix we will create. The view matrix is like the most important bit in all this. It says this matrix will transform vertices from world space to view space. What it means is that all the vertices you define, all the faces, all the edges are like in world space. They have this coordinate system, and they are like located based on the origin from the 0, 0, 0 point, and just living there. But the view space is the most important part for us, because the view space is basically the transformation of those points based on where you look from. So from where the camera is on. And this is the most important part on how to make this projection. And you only have to do the part on the very first screenshot. You have to create the view matrix. It's make view matrix, and it's part of the library. You have to give it the camera position, the focus position, like where you want to look at. In my case, it's the center of the model, just calculated it somewhere else. And then the up position, it's just needed for reference. And then all I have to do, I have to go to all the vertices of my model I want to display and just transform those vertices based on the matrix I just created above. And I just have to do it every time the camera changes its position. And then you can see the only thing I have to change is from the left part, where I just wrote it down myself, move to there, line to line to there. I have just to say, well, instead of doing it hard-coded, do it based on the vertices. Do the stuff above. For every change position of the camera, update the vertices, and then I create a path and then say, move to this vertex, then line to this vertex, and so on. And I just do it in a for loop until I just traversed over all the vertices. And then at the end, I just have to say, then draw the path I just defined for my model onto the canvas. That's basically this. Like doing this with all the stuff I said before, you will already see that you can mimic 3D representation in 2D. Like we will get the projection in 2D. It's nothing more than that. What I have done additionally, of course, to make it more fun, to make it more appealing, I added rotation. Like I added a gesture how I can rotate the camera, some scaling translation, like change the position. I cheated it currently with some transport widget to make it easier, but I can just show you in a minute. Then I made the face order because I want that since it's 3D, like I want to print the 3D object in 2D, I have to make sure I print the foremost face at last, because otherwise I could see through the object. And at last, I made some easy light calculations to have some kind of light representation, but it's just bare bones and not a real representation. You would need some ambient light, how's it called, on top. Otherwise, it will look pretty hard. But you can see it right there after that. And now I will just go over and show you this screen. And this is like my current, this is my iPhone screen. I have here my iPhone on top of me. And this is like the current version of the app, of the implementation. And you can see if I now, like with one finger, change the position, you can see like this element changes its position. Like every time I change the camera, the vertices get calculated new and my custom painter repaints. For example, then I can say draw the edges, so I can see all the edges of it, which is basically just the same, just painting the edges. And I can make some light calculations. This is what I meant earlier, where you can, like, for example, you can show it from right here and then move the light, and you can see how the light changes based on where my light is. And the last part that's very interesting is when I say rainbow colors, you can see if I put the light away because it's just bad here, it changes the rainbow colors all the time if I change the position, because the order changes all the time. That's what I was referring to earlier. So if I now look from the front, I don't see the start of the sword, I just see the tip. And this is the ordering I was referring to. Otherwise, you would see the end of the sword. And this is why I have to change the order all the time. So this is like my current implementation of that, and not really using anything more of what I just said here. I just shown you here. What I want to do next is, since I have some basic cover for the view, you can think about, I could transform the stuff. I could add interactions, maybe editing, enhancing the models, even like making it an editor-like approach. And I still need to think if this will ever be package ready, because my approach tackles many use cases. Maybe it's a better idea to just have it the code base open source and everyone can do their own thing with that, instead of making a package which has to enable every possibility, like editing, showing, and don't know what it is. So I have to see about that. But what I've done so far, I've open sourced the code. You can just go right there. It should be available now. I just made it public. The slides will be available later on, so you don't have to write it down now. You can look it up later. But you can see all my source code right there. I would say make a fork, because don't use it right now, because I will change a lot. And I might brick something on the way, so better make a fork which works and make some additions on your own if you're interested. And you can drop some issues per request or make forks, whatever you want, and see where it goes. That's it for now. I hope it was an interesting topic. For me, it's very interesting to do that. I think there's a lot of potential, and Flutter is very, very has a very good performance. So doing that runs on steadily 60 FPS right now. I don't have any problems with that. Flutter is very fast in rendering stuff like that. And I'm very, very happy with the results so far. And I will see what I can do with that and see where this journey takes me, if I will ever make a package out of it or whatever. I'm not sure yet. We will have to see. But yeah, if you have any questions now left, feel free to drop your questions now.
Thank you a lot. It was really interesting and pretty heavy, I would say, also from the side, because it goes down to this 3D stuff, algorithm, algebra, and so on. It's pretty intense, but it was quite insane what you achieved with your example, and it's also quite cool that you actually open sourced it. So
yeah, sure, of course. Like my benefit was, like, I had computer science or computer graphics when I was in university, and I had a very good professor who taught it very well, and I remembered a lot of it, and just had to look up some reference and so on, so I could apply a lot, which helped me a lot. And yeah, I think open sourcing it enables everyone to take a look, and you all can see that it's actually not too much magic. You have to have some basic understanding of the arithmetic behind it. That's what I was referring to earlier. But once you understand all that, it's not too hard. Really, like, take a look. It's open source right now.
Yeah, there is one person who wrote that. Stanislav wrote that the brain just did like 100 push-ups. It's pretty much the same for me. I think it's even like what you did. It's actually worth an article as its own, because I think if you have more things to explain, it would be really nice to even read it.
Yeah, true. I just have the
more
time to
medium.
write it down.
That sounds awesome. I don't know if there are some questions in chat. I've seen there was already one question answered right away during your presentation.
Yeah, easy.
Yeah, that's so far there are no questions. I think people are just astonished by the results that they have. There is a link to the repo, to your repo that you provided in comments, and I think people could then reach out to you in case of questions. But
yeah, very important there. Feel free to hit me up on different. This is why I showed my social media at the end. Hit me up on Twitter. I will be the most active, where I will probably tweet my progress and so on. You can even message me there. I have my DMs open. But you can also create issues if it's like particular on this topic. Whatever you like, you will get to me somehow. I'm not too close or something. So if you have any question on something, what to get in touch and need any information, just hit me up. Yeah, no problem.
I see right now there is just like a really short one. What's the format of the 3D model of the sword?
Oh yeah, it's OBJ. Is it the correct one? Yeah.
OBJ.
Yeah, OBJ. Yeah, OBJ. Yes. I just it was the easiest for me because there are a lot of free models available in this format. But basically, in the source code there is like one function which says pass OBJ. And there you can see how I did it. It is actually not magic at all. You can do it with every kind of file. I think my next thing would be to allow not only OBJ but FBX is the one which is very used in Unity, and I know there was another one, like two ones which are very famous as well. You will see it's not too hard. It's just reading some strings and parsing it.
Nice. Then we're looking forward for that. Thanks you a lot again.
Sure.
Now we're going to jump to the next talk. It's Vince. Please present yourself and tell us what you're going to talk about today.
Yeah. Hello, everyone. Welcome to my talk. My name is Vince Varga, and I would like to talk about Dart null safety and share some of the migration tips or some of the issues that we had during migration. Then, just one sec. Okay. So yeah, this is kind of a modified or botched CV of mine to have a quick introduction of me, of myself. I live in Munich. I moved here from Hungary. I'm a self-taught software developer. Before that, I studied physics. And then I realized that I don't want to be a physicist for the rest of my life. So I picked up software development. I started with JavaScript, HTML, CSS, and then tried out a couple of things. And eventually I ended up with Flutter, and I liked it so much that I actually started organizing the meetups in Munich. And I also, whenever I can, I organize, I write some open source code, both in my free time and whenever my employer lets me to do that. And just wanted to thank you for organizing the event and also for attending the event, and also for the other speakers for just coming and sharing your knowledge with us. Just two quick plugs. I'm after the pandemic hit, I couldn't really organize meetups anymore, and I just kind of missed that I could learn so much from others. So I started a Flutter podcast. It's called Flutter 101, so 101. There are a couple of episodes out there. AWS, I don't know, Alfred, background services, and many more. So if you want to check it out and subscribe, feel free. I'm currently working at MediaMarkt Saturn. We have a cool mobile app team of around 10 developers. We have team members in Germany, Spain, Berlin, Munich, Ingolstadt, Alicante, Barcelona. So if you are looking for a Flutter position, check it out. You can also write me later for the links. Then, of course, opinions are mine. It doesn't necessarily reflect everyone else's opinion on my team, but this is the opinion that I basically. This opinion is basically informed by a migration that we are doing at MediaMarkt Saturn. Then a quick outline. I want to give a quick intro to null safety, because I don't know if you all have experience with that, and I kind of wanted to make the talk interesting for both beginners and maybe a bit more experienced people. Then I will show a couple of code examples and then go to the migration steps or the available tools and sort of like what the expectation versus reality was in our case. And then I will talk a bit about unsound null safety, which was very important for us because we have a huge code base, and that was basically the way we are migrating the code base. And I will share a couple of tips of what we learned so far. The Dart null safety support is based on the following 3 core design principles: non-nullable by default, incrementally adaptable, and fully sound. So let me give a short description of what these things mean. So non-nullable by default means that unless you tell Dart explicitly that a variable can be null, it's considered non-nullable. So I will talk a bit more about that. So basically, it's by far the most common choice for real-world APIs. So it makes a lot of sense that a modern language also picks that behavior as default. Incrementally adaptable is also very important, so that we can migrate incrementally from for an old code base, and we can mix null safe code with non-null safe code, and we can kind of shift our legacy code to modern null safe code. And fully sound, this enables compiler optimizations and leads to fewer bugs and smaller binaries, faster execution, and all of that. I think to me, this is the fully sound is, I think it's interesting, but to me as a software developer who needs to ship product, this is the least exciting part. Just to give a couple of other language examples. So Swift is sound, for example, but Kotlin and TypeScript is not. Kotlin, I think, is not sound, so that it can interoperate with Java. The same similar story is also for TypeScript because it has to work with JavaScript. But for example, Swift and Dart is fully sound. Dart 2.12 added support for sound null safety. Let's take a look at what this actually means. It means that the types are non-nullable by default, and if a variable can contain null, we need to explicitly say that it can contain null values. So this turns runtime errors into edit time analysis errors. And why is that important, that we turn runtime errors into analysis errors? It's a much quicker feedback loop. So just think about how a runtime null error happens. It happens over the course of weeks or days, depending on how quickly you release the apps and how quickly you notice the bugs. So you write a bug, you release the app to the app stores, you roll out your application, then notice something went wrong in your crash reporting tool. Then you need to find the bug, you need to solve the bug, and then you need to release the app again. So compare that with analysis errors. It's basically just seconds or probably even sub-seconds, and you can fix the error right away. So it allows you to have a much quicker feedback loop about your code. One thing I want to mention is that null is not bad. Not knowing that something is null is bad. So sometimes it totally makes sense to use null to indicate that there's something missing or something is optional. So you don't, only because null safety is coming, it doesn't mean you should never use null. Then non-nullable by default kicks in if you set your SDK constraints to 2.12 or later. The step 0 is to install a version of Dart and or Flutter that support null safety. Basically, today it's, I mean, you just need to update Dart and Flutter and it will be ready to go. Then step one is to basically update your environment SDK. This is the pub/spec.yaml file. This is a snippet from that. You can do it manually, or even better, rely on a migration tool that the Dart and the Flutter team is providing us. Then if you do that, use the migration tool, then you don't need to do this. And yeah, let's see some code examples. I will quickly go through a couple of code examples just to show you what null safety means in case you don't know it. The examples are coming from the null safety code lab. So definitely, I don't go through all the examples. I just want to give a taste of what null safety looks like in case you never used it in other languages, in TypeScript, Swift, Kotlin, or just obviously Dart. But I really recommend checking out the code lab. Then, so this is what it looks. This is, let's take a look at the first examples. Example, we have an integer a in line 3. We try to assign a null value to this integer. And in this example, I wanted to demonstrate that when you opt into null safety, all types are non-nullable by default. So as we didn't specify the question mark after the int, a is non-nullable, so you cannot assign a null value to a in line 3. So you will get basically an analysis error or compile time error, depending if you configured your IDE correctly. But latest at compile time, you will realize that it's not working. So you cannot assign a null value to a type of int. So one way to fix it, it might not be the so is to not assign null, but obviously sometimes you want to assign null. So in which case, if you want to make a nullable, you just need to put the question mark behind the type. So int question mark or string question mark, or obviously it works with any other values as well. And in this case, so a is now able to store an integer as well as a null value. It also works for generics. Type parameters for generics can be nullable or non-nullable. You can find out what the intention was with this code by reading the variable names. In legacy Word, it used to be okay to write all of this, but now with null safety, it is not. So let's take a look. The first thing is a list of strings in line 3. There's nothing wrong with that. It's non-nullable, and every value in that list is non-nullable. It's a string, so there's nothing wrong with that. On line 3, the variable name implies that we want a nullable list of strings, but the type says it is non-nullable currently with null safety enabled. That's why on line 7, when we try to use this, we get an error that we must assign the variable before we use it. The other example is on line 4, that we say we want a list of nullable strings, but as a second element, we try to put a null in the list, and that is not possible after null safety. So let's fix these errors. We just need to strategically put a couple of question marks in the code. So on line 2, on line 3, we make the list itself nullable. So it will be fine. Everything's good. And on line 4, we make the elements of the list nullable. So what was before illegal or what would cause errors is now okay, and we can use null values. Then quick couple of examples. Let's take a look. Sometimes it can also happen that Dart is unable to verify that something is nullable or not, but we in fact know that it is not null. So on line 8, we cannot assign to a type of int because in theory, the first element of a list of a nullable integer could be null. In this case, it's not null, but it could be. So Dart cannot verify this for us. Similarly, on line 9, the function could return, in theory, based on the return type null, as well as an integer. But if you check the function body, it always returns -3, which is not null. So again, the problem is that we developers know that it cannot be null, but Dart cannot verify that the example above will it cannot verify, and the example here will not compile. So one way to fix this error is the null assertion error, which is the exclamation point. You can see it on line 8 and 9. So this is, we can use it if we are sure that a nullable type is not null. In this case, Dart will treat it as non-nullable by adding the exclamation mark, the null assertion operator. After the expression, we are telling Dart that the value cannot be null. You need to know that this operator is unsafe, so don't use it unless you are very, very sure that the expression is in fact not null. If you are wrong, Dart throws an exception at runtime. But if you just add the exclamation marks, then this program will compile again. Just remember that this is a unsafe operation, and just reserve it for cases when you really know that a nullable type is actually non-null. Dart can also track where variables are assigned and read, and can verify that non-nullable fields are given values before any code tries to read from them. This is called definite assignment. So uncommenting the if-else in the example will help the analyzer error disappear. So you can read the errors. It says, okay, non-nullable local variable text must be assigned before it can be used. Let's remove the comment here, and then Dart can figure out, even if it's Dart can figure out that by line 10, the text will be non-nullable. So it doesn't need to be, doesn't necessarily need to assign it in one step. It can basically analyze that, okay, if else, either of those will execute no matter what. And the errors will be gone, and you can use text, and it will know that it is a non-nullable string type. Dart can also keep track of when you check for nulls. In the above example, we want the get length to return 0 if the str function input is null. Currently, we have an error on line 4 because we try to access the length property of a nullable string, and that we cannot do. We can get rid of the error by adding a null check. Of course, there are other ways to work around this with question marks and double question marks and so on, but let's focus on the null check. So we add the null check, and we check if the string is not null. If it's null, we return 0. Otherwise, we access the length of the string, because by that time, on line 4, we know that the str variable is not null, because if it was null, it would have the function would have already returned 0 on line 2. The same is true for throwing, so it will know that, okay, if it's null, this function throws. So on line 4, we know that the str is not null. Just to reiterate, be sure to check out the code lab. I didn't show a couple of things that were a bit more advanced and didn't really focus on the code labs. And of course, I just don't want to show the entire code lab. I picked the first part of the code lab to show just kind of a feel for what null safety looks like, but I skipped the late keyword for circular references and lazy initialization. But I recommend you to check that out. All of this, I think what's most important for me is that the code reviews are much simpler than, I don't know about you, but the constant confusion that we had before with null safety, that, okay, we used the @required, we checked the null value in assertions, and writing all of that code is just annoying. It was always coming up in code reviews that, okay, why do you not require? Why do you make it non-required? Why do you not assert? Why do you assert? Because in one layer above, you already checked if it's not null, and things like that. And these are all good feedback from my team, because we want to keep our code consistent. But these kinds of checks shouldn't be done by humans if a compiler can also do it for us. Let me talk a little bit about soundness. So I think the long story short for me is that the code will be smaller and faster because runtime null checking is no longer necessary. The compiler can get rid of the now unnecessary checks, fewer instructions, and sometimes most of the heavy lifting happens at compile time. I can really recommend you this article by Vijay Menon titled Dart and the Performance Benefits of Sound Types. It's also referenced in the docs. And the important part for us was the null safety is incrementally adaptable. So how is this supported by Dart? Maybe a little known feature, at least I didn't know it, or more like I didn't realize its importance before, is that a single Dart SDK can simultaneously support multiple versions of the Dart language. So the compiler can determine what version the code is targeting, and it interprets the code according to that version. I think it's an important feature. Then, like null safety is an important feature because and also the language versioning is an important feature because code that used to compile cleanly before null safety wouldn't otherwise compile now. So yeah, yeah, I think yeah, that's pretty much it. So what can we do when we cannot migrate the entire application or our entire package, because basically your Flutter application is also just a Dart package. But what can we do when we are not able to migrate all the files in the package to null safety at the same time, which is what we would do with if we just change pub spec and we don't do anything else. The per library language version selection lets us do that. For us, it's pretty important because we have over 10,000 lines of code. It's test, it's generated code, and it's also logic. So what you can do is you comment at the top of the file that, okay, add Dart equals Dart 2.7. And then for this library, which is if you don't specify otherwise, it means a file. In this library, we don't want to use null safety. We opt out. We want to use the old version of Dart. And then you don't need to update everything at the same time. So this is I think it's very helpful for migrating a bigger package or a bigger application. So I would like to talk a bit about migration. I think the expectation that I had watching like well-prepared YouTube videos is that it's super easy. You just need to basically wait for the packages that you depend on to migrate, then migrate your code. You can use an interactive migration tool, run the static analyzer, run your automated tests, maybe run a couple of manual tests and enjoy. I don't think it was actually the case for us. But the Dart team has done a good job with migration tool. And also this expectation, this is very true for smaller applications or like individual packages that you might have published on PubDev. It is really working this way. But for bigger projects, it didn't really work that way. One thing I wanted to mention is that the Flutter 2.0 and up, like 2.5 today, and the Dart null safety migration don't need to happen at the same time. So you can have old Flutter with null safe code. You can also have new Flutter with non-null safe code. So it doesn't have to happen at the same time. In our case, it happened. Just a couple of migration tools that the Dart team provides is the pub outdated command. It checks the dependency status and shows the dependencies with and without null safety support. I will show an example output. You can also upgrade your dependencies to the latest versions supporting null safety with the pub upgrade command. It updates everything automatically. We tried initially to basically manually upgrade just the minimum set of dependencies so that we can keep our pull requests small and we can keep our changes small and basically not having to track down all the breaking changes in the different plugins. It didn't really work out for us. We tried it. We changed the versions manually, and then after a couple of changes, we realized that, okay, this is not going to work. So we used this command, and then it upgraded everything for us. And then we just had to fix a couple of warnings or errors, and then it was actually very handy and very helpful for us. So this is the example of the pub outdated command. It lists your dependencies that don't have null safety support. Then you can check these out and try to fix those. There's also a very great Dart migrate tool. You can basically get your unsafe code and converts it to null safety. The tool proposes edits, and then we can guide the tool by adding these hint markers to overrule the tool's decisions. And maybe there's something that the tool detected as nullable, but you know it is not nullable, and then maybe you add a late keyword or things like that, and then you rerun the migration tool, and then it will analyze again and make some tweaks. It also supports incremental migration. So on the project's files, on the left side, you can see the green-black checkboxes. And if you uncheck it, we opt out of migration for that file. And that file will be unchanged, except for this version comment that will opt the file or the library out of null safety. So I can also really recommend those. You can also migrate by hand. I would only recommend that if you already did this migration before. You just need to update your SDK constraints in the pub/spec YAML file, fix the errors, run the tests. It works very well for small projects if you have experience doing this, but only recommend it if you really small projects and if you did this a couple of times. Then this is what I did basically for this smaller Dart plugin, this smaller plugin. I just changed the Dart SDK, fixed the errors, and that was it. I didn't use any other tools because the plugin didn't have much dependencies, and it was much faster that way. I didn't need to run the migration tool. So that's also an option. Of course, I recommend the migration tool. Then again, the expectation, I think the reality, what we experience so far at the company is that updating the dependencies are a pain because sometimes, I mean, it wasn't like a huge pain. It was a slight annoyance that we had to check the versions of, we had to fix a couple of outdated things. We also had to fix the generated files in one go. We couldn't use because otherwise the build runner wouldn't run. So we had to fix all of the files that were used in the build runner. But I also think that like we are using temporary unsound null safety, which is basically unavoidable for us because one gigantic pull request would be unmanageable. So life without incremental migration would look like this, that we just look, here is this huge pull request. Don't review it, just accept it and hope we don't break everything. So yeah, anyway, the unsound null safety is pretty important because so it's not great, it's not terrible. It has a couple of caveats that you need to pay attention to. So you need to understand that basically null can escape or leak into null safe code from non-unsafe code. So it's a bit annoying, but for us, the alternative would have been to let the migration tool run and close our eyes and merge. So it wasn't really, it's worth considering, but it wasn't a great option for us. Let me skip this. some things that we learned that were confusing first. And of course, if I say something that you have a better solution for, or if I'm mistaken, let me know. You can contact me on Twitter, LinkedIn, anywhere. For example, you don't need to migrate every dependency yourself, even if the code doesn't look like the dependency doesn't look like it was migrated. So that's the first thing. You check if it was released a no-safe version. Then you also should check the pre-releases, because it can be that the dependency was actually migrated but not yet landed as a stable version. So definitely check the pre-releases. Then you can also ask the maintainers, maybe they are already working on it. Check the pull requests and forks, because maybe sometimes the maintainer is gone, but the community is still there, and they try to submit pull requests where they already migrated the code for you. Or just check alternative packages. One example, I think the flashbar package was basically not updated, and someone created another flashbar package, and that was really useful for us. Another tip is that merge as often as possible. You want to keep your delta between your migration branch and your main branch small, so that it can be reviewed, it can be tested, and then others can already start using your code. One thing I think I forgot to mention is that we didn't want to have a code freeze. We didn't want to let this affect the features. We wanted to allocate some time to migrate incrementally, but the majority, like 80%, 90% of the team was working on features. So that's why we also went with this approach. Only local variables can be promoted. I have a couple of slides more. So in this case, the foo class has a field A, and you can see that we check that foo A is not null. And you would expect that now with the type promotion in line 8, there shouldn't be any errors, but there is, because let's say we have a strange foo where we extend the original foo, and then we can make this silly getter that randomly returns string or a null. So that's why it actually makes sense from Dart to say that, okay, look, this is not correct, and you need to handle this. And one more thing is that Dart is very pessimistic, so it wants to prove that everything is correct. So what you can do is basically create a local variable, and then you can check the null values. If you want to learn more about these edge cases, check the type promotion failures. Fixing type promotion failures document. It's very good. I can really recommend it. One more thing, that the prefer type promotions to the null assertion operator. The example that I have here is that we have two fields, A and B, and we assign those. And let's say we check for foo.a, and we could use the null assertion operator in line 12, and that would silence the compiler, and it would tell the compiler, okay, I know what I'm talking about. I checked A is not null, so it should be fine. But what happens if someone comes and then forgets about the if check, and then changes that foo.a to foo.b, then it will cause a runtime error. So I think that's why I recommend to always just create a local variable. It's a line longer, but this is safe. You also might want to disable analyzer rules temporarily. So we allow legacy import into null safe, and we also allow unnecessary null comparisons because of the mixed mode, where null values can leak into basically from unsound null safe, from non-migrated code to the migrated code. So you can also help your team transition seamlessly by sharing common scripts and run configurations. I can really recommend the Dairy package. It's a script manager, and then you can hide these flags behind these Dairy scripts. Of course, if everyone on the team is using the same library, you can just use, for example, IntelliJ's run configs, which is very much better. Yeah, we had to migrate from Mocktail, from Mockito to Mocktail, because Mockito null safety migration just sounded like so much pain. So we decided to just, we found Mocktail, and it was like, oh my God, this is so much easier. We will just change that. So we completely dropped Mockito, and we are using now Mocktail. So this is a really good package as well. Running a single test file in IntelliJ was annoying because we always had to, basically we had to add additional arguments for a single test file. Otherwise it would fail. If you have a better workaround for this, let me know. But what we did is that what I basically always do is when I run a test, I change the configuration and then I run the tests actually. One more thing, imperfect code will stand out more with null safety. So you need to have these conversations that, okay, how do we handle cases when null was not handled before? So you can use the bang operator, the null assertion operator, because if it worked before, it will probably also work for now, for a while, and it actually doesn't make things work. So I think here is, maybe you can accept it because, I don't know, perfect is the enemy of good, but you can also, of course, you need to think about return null. You can also throw, but Dart has no checked exception. I can also recommend the either class, I think, in the Dartz package, or you just take a breath and figure out how you want to handle it cleanly. Yeah, and in the end, once everything is done, your code should be smaller, faster, up to date, and you can keep up with the ecosystem and the community. The code is also much cleaner, and I think many more. Just 3 resources that I want to plug. Of course, the official Dart documentation. It's great if you like to read. Really recommend everything to just read it through. There are also great YouTube videos, both from the Flutter team and from the community, from conferences and things like that. And I would, if you are a podcast person, I would recommend the No Safety episode with Randall Schwartz. This is my podcast, the Flutter 101 podcast. And it was a pleasure to talk to Randall. He explained so much to me. So just recommend you check it out. This is actually the first time I gave this talk. I was so worried that, 34 minutes. But please, if you have feedback, reach out to me on Twitter, LinkedIn. I would be happy to improve my slides in case I ever present it again. And if you have questions, let me know. Otherwise, thank you for listening. And yeah, that was it.
Awesome. Thank you a lot. It was a really nice talk. In my pet project, I used didn't use null safety yet because it was always like a huge pain for me to migrate it by hand. But now with all the tips and really nice advices, I probably will try it.
Yeah, hopefully it will help you and others as well.
Thank you a lot. Are there any questions? I've seen there was a question that was answered during your talk again, like it was in the previous talk with Renee. So far, I don't see so many. I think otherwise, I think that people will reach out to you on Twitter if there is anything. But right now, we will go then straight to the ask us anything. If there are still people who would like to shoot some questions to Renee, Vince, or me, or Kevin. Kevin is there as well, as I see, in a darker room. But yes. Are there any questions, or maybe there are questions between the speakers? Feel free to do it. As I see there, like in the comments, there is nothing. I think everyone is waiting for the socks lottery, the most interesting part, and the weather is today the best.
Yeah,
okay.
I have a rooftop flat. I'm just
heating like in a sauna. Okay, I don't see any questions popping up. I would then tell to everyone that Oh, okay. Let's first roll the wheel. Mike, please do it. And the winner is Mike, another Mike. I hope it's not the Mike that is in our, on the background, but Mike Borodin, yeah, congrats. Please write to us in the meetup group because we need to contact you to give away those shiny socks. Thanks everyone for attending. And yeah, thank you all people to participating, especially for speakers. For the next speakers who would like to give a talk, we will give away Flutter bottles. So please reach out to us. That's it for today. Thank you a lot, and see you.
Thank you. See you. Bye-bye.